Welcome to the video for skill number 58. I can factor polynomials and use the factor theorem. We'll begin our notes on page 58A, factoring polynomials. The factor theorem says, for any polynomial p of x, x minus a is a factor of p of x if and only if p of a equals 0. In example 1 we ask, is x plus 7 a factor of p of x? And we give the equation for p of x. There's two ways to apply the factor theorem. One possible way is check with synthetic substitution. And so I did synthetic substitution here. As a quick reminder, I put the a value in the box, which is -7. And then I put the coefficients along the top row. 2 goes down to 2. 2 times -7 is -14. We add those and get -17. Multiply that by 7. Add those, get 119, etc. And in the end we get a rather large negative remainder of 40,825. Because the remainder is not 0, x plus 7 is not a factor of p of x. We can also check this by simple evaluation. We take the value of -7 and we plug it into our polynomial. So we get 2 times -7 to the 5th minus 3 times -7 to the 4th plus -7 minus 1. If we evaluate that all out, we get the value of -40,825. Since p of -7 is not 0, x plus 7 is not a factor of p of x. Typically this is going to be the fastest way to determine whether that the number is in fact, or the binomial is a factor. Though sometimes synthetic substitution is faster and it solves two problems in one go. We'll continue our notes on page 58B. Factor by grouping. The meat of the lesson and the skill is learning how to factor by grouping. And the purpose of factoring a polynomial is so that you can find the roots. We did this in the last unit when we were factoring quadratics, and now we have cubics that we wish to factor. So factor by grouping is one method to do that. Step 1 is to factor out the greatest common factor. And if you notice in this polynomial, all four coefficients are factors of 5. So I was able to factor a 5 out. 5 times 21 is 105. 5 times 35 is 175. 5 times 15 is 75. And 5 times -25 is -125. Step 2 is grouping, and grouping is actually really easy. For the grouping, we're just going to group the first two into parentheses and then the next two in parentheses. And you notice because I put this in parentheses, the negative distributes and that minus becomes a plus. This is a really common spot to make a mistake, but fortunately the problem has a check later on which will help us catch that mistake if we ever make it. Step 3 is to factor each group. So our first group of 21x to the 3rd plus 35x squared, we can factor 7x squared out of both monomials. 7x squared times 3x is 21x to the 3rd. 7x squared times +5 is +35x squared. So the first group is factored to that, and then we want to factor the second group. 15x plus 25, the only common factor that they have is a 5, so we pull a 5 out and we get 5 times 3x plus 5. 5 times 3x is 15x, and 5 times 5 is 25. And if you did it right, we should have 3x plus 5 on both of these. If you do not get the same value in the parentheses here between these two things, either you did it incorrectly or the problem cannot be factored by grouping. I will not give you a problem that cannot be factored by grouping and tell you to factor by grouping. I can't say the same for the textbook, though. It may do that. All right, and here's the note. If done correctly, these should be the same. So then we can write out our groups in the factored form. So 21x to the third plus 35x squared became 7x squared times 3x plus 5, and then 15x plus 25 became 5 times 3x plus 5. And finally, once we have it written out like this, step 4 is to factor out the common binomial. Because both of our pieces has a 3x plus 5, we can factor that out to the very front. So we get 5 times 3x plus 5. And what's left inside is 7x squared minus 5. This is like saying if you had AB minus CB, we factored a B out, and we are left with A minus C. So in this case, A, C, and B. And then the final step is to check for any further factoring, and it would appear as though we don't have any difference of squares. There's no other factoring that's readily visible to us. So the problem, as far as we know, is complete. And we can move to the next one. All right, for example 3, we're asked to factor by grouping, and we're given the polynomial 2x to the third plus 10x squared minus 2x minus 10. Step 1 of factoring by grouping asks us to factor out the greatest common factor. Since all these numbers are even, I know I can factor a 2 out, and we get 2 times that value. Step 2 is to group, so we can group the first 2, and we can group the second 2. And notice we got the same sign problem going on where the negative becomes a positive. So be careful there. If it's a plus, then it doesn't really change, but this negative condition can cause problems. Step 3 is to group each or factor each of the 2 groups. So our first group can factor to x squared times x plus 5, and our second group factors to 1 times x plus 5, because the only factor that they both have in common is 1. Step 4 is to factor out the common binomial. Remember, if you had AB minus CB, you can factor the B out and have A minus C. So in this case, our B is x plus 5. So we're able to factor that out, and we're left on the inside with x squared minus 1. Step 5 asks us to check for any further factoring, and in this example we do have further factoring because we have a difference of squares here. X squared minus 1 can factor to x minus 1 times x plus 1. And you thought we had left quadratics, but no, in fact, factoring quadratics is still a key piece. So I've written down the 3 common factoring scenarios that you'll see here when you do factoring by grouping. We have the difference of squares, and then we have the 2 perfect square trinomials. And we'll finish our notes on page 58D. Another type of factoring that we have is the sum or difference of 2 cubes. The algebraic general form is a to the third plus b to the third is equal to a plus b times the quantity a squared minus ab plus b squared. So this is used when you have 2 perfect cubes. I've shown 2 examples here. In this case, a is x, and in this case, b is 3, because 3 to the third is 27. In the second example, it may not be as apparent, but we have the value 2y to the third plus 4 to the third. So we're able to write it as a plus b times a squared minus ab plus b squared. The difference of cubes, it looks very similar, and it's easy to get these two formulas mixed up. So it would benefit you to practice these a couple times more than normal, just so you can see the difference between the two of them. But the process is still pretty much the same. I've provided one example down here that says factor 6x to the third minus 384. The first step always in factoring, always, 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 is to factor out the greatest common factor. And in this case, they're both multiples of 6, so we can factor a 6 out, and we get x to the third minus 64, which happens to be a difference of cubes. So our difference of cubes, where we get a is x and b is 4. So we have x minus 4, and then x squared plus 4x plus 16. And that's as far as it can get factored. For skill 58, there is 3 principles you need to know. The first is the Factor Theorem, which states that for any polynomial p of x, x minus a is a factor of p of x if and only if p of a equals 0. Basically, that means plug a into the function, and if it evaluates to 0, then x minus a is a factor. You should also be able to do factoring by grouping, and you should know the sum and difference of cubes.